first forget about direction or vector. I will make it simple. Let's say you have, uh, sorry, let's say you have this point here. You are at 2. You need to go to 8, right? This is a line, right? Let's say this is a line, and this starts from 1 and it goes up to 10, right? You are standing at 2 and you want to go to 8. If I ask how much is this distance, right? How much is this distance? So you can easily say that if I'm at 2, I want to go to 8, how many lines are in the middle? So 2, 3, 4, 5, 6 and 7, and we are at 8. So it is, and let's count how many steps do I need to take. 1, 2, 3, 4, 5, and to reach 8, we need to take 6 steps. So we get the same result when we say 8 minus 2, our final value, minus our initial value, and we will get the middle value. So this distance right here is what we need. Let's say with another example, if you have, let's say if you have 2 books and your goal is to get 8 books, how many books do you need more to reach 8? So you have 2, how many you need? 6, and you will get 8. So this value we can get from the final value minus initial value. We don't have any direction yet, but for this example, let's say you have P. You want to reach capital P, right? And this capital P is at X, Y and Z. And you are at X, Y and Z. You need to reach XY, Y1 and Z1. But this vector give us 2 things: where you at and which direction you are facing. So let's say I am at 1, 0 and 0. So if I'm saying 1, X has minus and positive, I'm saying at positive 1, and Y is 0, so there is no Y, and Z is 0, so I'm standing here. And the direction part we need to calculate, but we don't need here. So just remember this, we need to go here. So if I say I need this distance, but I need the direction also. If this point is here with same value, so you need to go from this to this, and we need direction. So if I somehow get this value, I will get this direction and plus the distance from origin, right? From origin. If I only get this value from origin, you need this value from the origin, and origin it as 0, 0, 0. So we don't need. But if I say this value and this value, so how much do I need? So I will just subtract this from this. In Houdini, the subtraction will be the part of Houdini backend. We don't need to worry about subtraction or direction. We will just understand the concept here, and which is when you subtract your final location to your initial location, you will get the same. You will get your direction where you want to go, and your distance, the amount, the magnitude, you need to reach there. So let's say in this example, I will make it more clear. If you have, let's say if you are here, right, your point is here, and this is origin, this is 0, 0 and 0, and this is your final P where you want to get. This is x1, y1 and z1. We can say dash, and in this case I will just use a different color, and I will say let's say bluish purple. Okay, and I will say you are at x, y and z. You need to go there. So if you are at the center of your grid, right, it's easy for you. You just need its location from the grid, this location and this direction, because here you just need, because this is your initial point, this is your initial point, and whatever you do in this grid, this is your x, this is your y and this is your z. If you say I'm at here, you just need its location from the grid, because grid, we say our initial value is 0, 0, 0. So if you add, multiply or subtract, you will get this, just this value. So here if you calculate this, but you are not at the initial center, you are at this point. So you need first this point. So where does this point from the grid? You can just subtract this, because we don't have the initial location, because initial location at the center of the grid is 0, 0, 0. We just need to have this, and when you subtract this from this part, you will get this direction. So where you need to go and where is your initial location. Last example I will give you to make this completely clear is, let's say you want to go here, you are facing in this direction. If you move in this direction, you will not reach at this point. So if you say you want to reach here, but you are standing here and you are facing this direction, you are facing this side. So even if you start walking, you won't reach at your desired location, because you are not facing this direction. So what you need to do, you need to first know which direction, this point, which direction do you need to move to reach this point. So you will need a direction, right? And if it is x positive, you need to walk to your x path, and if this is, or let's say this is y positive, you need to your y path. But here you have the some random location, so you need its direction, and to get its direction you need a vector, right? Because vector will give you where is x, where it is in x, y and it is in z. So you will get a direction and you will get your distance by just knowing how much the distance, and the distance is, we can calculate easily if we have a vector. So you need to face the point where you want to reach, and to make your distance more or less, you can add some noise or any value, you can add values to other. But the important thing here is, if you need the displacement, you can just have the shortest path. But if you want to just know the direction and know its location, you can just subtract it, and you can add noise to your particles, your objects, to that same point. So I hope this is clear, because this works on this simple basic, you are at 2, you need to go at 8. So how much you want to move, and you can just get it by subtracting your values. So I hope this is clear, and that's it. for this video.